Hello, Algebra students, and welcome to your Unit 2 review video. At this point, we have learned everything there is to learn about linear equations and inequalities, and this will be a short review video over some of the questions that students often struggle with when it comes to what we've learned in Unit 2. I've got 4 questions that we're going to go through in this video. I'm also, if you can't tell, filming from home again, so bear with me if there's any technology issues with the screen recording. But we'll go ahead and get started. The first question is from our very first lesson in this unit where we talked about slope. This question is one of the questions that students find more challenging just because it's presented in a real world situation as opposed to just on our XY coordinate plane. The question asks, the graph below shows the height of Denise's houseplant. What is the slope of the line and what does it represent? Go ahead and try answering that question now. Make sure you answer both parts of the question. So what is the slope of the line and what does that slope represent? All right. So in order to find the slope, if we're looking at a graph to find slope, we're going to want to use rise over run. Here, it doesn't have the grid line, so you have to pay closer attention to where these points are. If I'm starting here, that number between 0 and 2 would be 1. So if I'm going to the next point, I'm going to have to go from 1 to 2, which would mean my rise is 1. And then similarly, this point here is right between 0 and 2, so it's also at 1. So I would be going up 1 and over 1, which is where this 1 over 1 comes from. And 1 divided by 1 just equals 1. So to answer that first part of the question, what is the slope of the line? We want to say the slope is 1. Now, when it comes to what that slope represents, it's really important that you're paying attention to the labels on the graph. So this over here is showing the height of the plant in centimeters, and that x-axis at the bottom, if that little gray bar would go away, you would see is showing the days or the time. So when we're rising 1, running 1, we are rising 1 centimeter and going over 1 day. Another way you can think of that is it's going up 1 centimeter in 1 day, going up 1 centimeter in 1 day. An easy way to say that is it's just growing a centimeter a day. So a possible answer that you could provide could look something like this. It could say the slope of the line is 1, and the slope represents how many centimeters the plant grows every day. One of the mistakes I see students make a lot when they're talking about what slope or y-intercept represent, for slope especially, students like to say the slope represents the height of the plant. Well, we can't say 1 is the height of the plant because if I look at this graph, the height's constantly changing, right? By day 4, the height is 5 centimeters. At day 7, the height is 8 centimeters. The height of the plant isn't 1. So we can't just say 1 is the centimeters or 1 is the height. You have to include that part about every day. It goes just back to slope being rise over run. If you're just saying the slope represents 1 centimeter, you're just describing the rise. We want to say 1 centimeter every day or 1 centimeter per day, something like that. So this was our first review question. We'll move on to the next one. The second one also is about plants. I'm sorry about that. But the second one says, Jonathan is growing a plant for science class. The plant started at a height of 3 centimeters. He noticed that the plant grows 2 centimeters every 3 days. And the question asks us to write an equation to represent the height of a plant and create a graph to show the height. I'm going to have you go ahead and do that first part. Go ahead and write an equation to represent the height of this plant. All right. So when we go to write our equation, it's going to need to include the 2 important things. We want to include somewhere in that equation that it's starting off at 3 centimeters. That's our starting point. And then we also want to include this part about the plant grows 2 centimeters every 3 days. Now, the information they're giving me there is a little different than the last problem where it was 1 centimeter each day. If it's growing 2 centimeters every 3 days, one thing you could do is calculate how much it grows each day, and that would use division. Or you could just leave it as a ratio or a fraction, since that right there is going to be our slope. So I've got some things I've written down. That slope, similar to that last problem, is your rise over your run. In this case, it is rising or growing 2 centimeters every 3 days. That right there is already set up as a ratio or a fraction, so we can just go ahead and change that to 2/3, and that would be our slope in our equation. When we were talking about that starting height, I was using the words like starting height because that is your y-intercept. That's where that graph starts. Our y-intercept is going to be that starting height of 3 centimeters. So your equation should have looked something like this. You might have used different variables, which is totally fine, also correct. I'm going ahead and using the x and the y since it is going to ask me to graph. But what this is saying is y, which is going to represent our height. Our height is starting off at 3 centimeters and then growing 2 centimeters every 3 days, or 2/3 of a centimeter each day, x being the number of days. This was the first part, is writing that equation. The second part would be graphing this line. Go ahead and describe for me what I should do to graph this equation over here on this graph. All right, for this, I'm going to grab this pen. In order to graph this, I'm going to start at our y-intercept, which is that 3 here. Now notice that this graph they've given me does not have the 4 quadrants like we're used to seeing. It doesn't have that x and y axis right here in the middle. We could add that in if we wanted to. So if you wanted to come in and just say, like, with a much straighter line than what I'm currently doing, if you wanted to go ahead and say, like, this is where my x-axis is going to be, this is where my y-axis is going to be, you could draw those in. In this problem, I am not going to do that. Do you know why? In this one, I'm not going to do that because in this problem, we don't need the negative numbers. We're talking about centimeters. Your plant's not going to be negative centimeters. And we're talking about days. You're also not going to have negative days. So because of that, I'm just going to use this side over here as my y-axis, and then this bottom part here as my x-axis. I'm not going to draw those horribly unstraight lines like I did. I'm just going to put those arrows there so we know. Now over here, I would want to start at our y-intercept. We already said that y-intercept is 3 centimeters. Sometimes you can relabel this with larger numbers. So if that starting height was 30 centimeters, I might say, like, well, let me count by a different number than 1. But here all the numbers are pretty small, so I'm just going to keep it as this is 0, and then each line represents 1. So I could go up and say 1, 2, 3, and then this would be our starting point there. The next part is showing that slope. So we said the slope is 2/3 to show that it's growing 2 centimeters every 3 days. If I want to plot more points, I'm going to do exactly that. I'm going to go up 2 centimeters after 1, 2, 3 days. And we can just keep doing that, up 2 centimeters after 3 days. We can keep doing that until I am out of graph. Or I'm tired of plotting points. But we're there. Notice when you're plotting these points, it should always be in a straight line. So my line should never start to bend with linear equations. Linear literally means like a line. It's a straight line. So if your line starts to bend, sometimes I see that when we're in person and students are plotting their points in front of me, that means you've changed the slope. If I am consistently going up 2 and over 3, though, it should be the same direction the entire time. Last part would just be to connect those points with this beautiful straight line I just drew. Now, there's one thing that's still missing on my graph. Do you have an idea of what that might be? Well, usually when we're talking about real world situations, there's labels involved, similar to that last problem we looked at. I need to come in. Usually the 3 things you're going to see is you're going to see a title on the graph, you're going to see a label for your x-axis, and a label for your y-axis. So I've got just like an example of what we could do. We could say this is the height of Jonathan's plant. We could call that y-axis the height of the plant in centimeters. And then that x-axis would be, that box is in the way, but it says time in days. So if you come back to look at it, it's showing that starting point at 0 days. That starting point is 3 centimeters. And we are going up 2 centimeters after 3 days, and it continues on. Hopefully we're feeling good about slope and graphing. We'll move on to the next question. Perhaps. There you go. Oh, and let me get rid of that. The next question asks for you to write the equation of the line that goes through the points -4, 0 and the point 0, 2. Go ahead and write that equation for me. All right. So we've talked about two different formulas for linear equations: slope-intercept form, which is y equals mx plus b, and then point-slope form, which is y minus y1 equals m times x minus x1. And in those lessons, I had recommended looking at the information you've got. For both of them, you're going to need slope. And then to write that equation, if you know the y-intercept, you would be using slope-intercept. If you know a point, you'd be using point-slope. But both of those formulas have got slope in it, so that's where we would need to start. If I've got 2 points, the coordinates or the numbers for 2 points, then we would want to use that formula there to find slope. Rise over run is the formula you're using if you've got a graph where you can literally count the rise and the run. But when you've got the coordinates and you need to find slope, this is what you're going to be using instead. One of the things that helps students is coming back up here and labeling the points. Remember, x is always going to come first and y will come second. Same thing for your other point. X always comes first and then y comes second. The 1s and 2s, if you want to say this is the first point, that's fine. If you want to say this is the first point, that's fine. But whatever you're saying the first point is, you're going to label both of them with 1s. And then whatever's your second point, you're going to label them both with 2s. So this is an example of how you could label them. I recommend labeling them, though, is just because a mistake that a lot of students make is they put or substitute these numbers into the wrong spots in your slope formula. Once we've got them labeled, we get our formula in front of us. The next thing would just be to substitute those numbers in. When you do that, it'll look something like this. The y2 is 2 minus your y1, which is 0, over x2, which is 0, minus x1, which is -4. Notice right here, it's important that you've got both of those negative signs. That's another common mistake students make. One of them is coming from this minus sign here in the formula. The second one is coming from the negative sign in the number. And it's important to have both of those because when you go to do the math, 0 minus -4 is the same thing as 0 plus 4, and 0 plus 4 is 4. For the numerator, 2 minus 0 is 2, so we're left with 2/4, and if you simplify that, you get 1/2. Now, part of the reason I wanted to do this one as one of our review questions is because the most common mistake students make with these is they stop here. They say, there's my answer, I'm done, and they move on to the next question. And there's a problem with that. The problem with that is related to what we just found. What is this? What am I looking at? Well, we said this is the formula for slope. We figured out the slope of the line. What is the question asking us to find? Well, the question wants us to write an equation. This is not an equation. This is just your slope. This is your m. We use m to represent slope. We still have an extra step where we need to write an equation. It goes back to what I was saying about those two formulas you have for writing equations. You've got slope-intercept form. You've got point-slope form. Since we've got points and slope, I'm going to use point-slope form, which would look like this one here. If you remember to do the second part, though, usually students are pretty good after that. Once you've got this, you would substitute your point into this formula along with your slope. It does not matter which point you chose to use. So earlier when I asked you to try this, if you wanted to use this point here, that would also get you the same final answer. I'm going to go ahead and use this one since I've labeled it x1, y1. When we substitute, it'll look like that. So I substituted y1 as 0, because y1 is 0. I substituted x1 as -4, since x1 is -4. Same as up here. Notice I've got two of those minus signs. One's coming from the formula. The other one's coming from your x coordinate. And then I substituted my slope as x, not as x, my slope is 1/2. That next line is me just kind of cleaning it up a little bit, is how I would describe it. That minus 0, taking away 0 is like taking away nothing. It doesn't do anything. So I don't actually need to write that minus 0. And then I also changed these two minus signs to a plus sign. The last thing we would want to do is distribute that 1/2 so that it's in slope-intercept form. So it looks like y equals mx plus b. 1/2 times x is just 1/2 x. Students aren't usually fans of doing 1/2 times 4, but multiplying a half is like the easiest fraction you could multiply by. It's just taking half of that number. So instead of thinking 1/2 times 4, just think what is half of 4? Half of 4 is 2. And so we're left with this being our final equation, y equals 1/2 x plus 2. One of the things I don't have typed in here, so I can't just like click a button and it'll appear, but I do want to mention is that for these questions where you're writing an equation from 1 point or 2 points or a table, anything where you have a point, you can check these. We did this in the lesson video a little bit, but I just want to remind you, since you do have that Unit 2 test coming up, that if you wanted to check your equation, one thing you could do, similar to in Unit 1 when we were checking just your one variable equation, you can use substitution to check. What I mean by that is if I want to check to make sure this equation is the equation that goes through these points, you could substitute your point, or both of them if you want to be extra sure, back into the equation and make sure that it gives you something that's true. So I'm going to attempt to do this with this pen. If I wanted to check using this other point that I didn't use to write my equation, we would substitute 0 in this equation here for x and then 2 for y. If I did that, instead of y equals, it would say 2 equals 1/2 x would be 1/2 times 0. Anything times 0 is 0, so I'm just going to go ahead and write 0 to save us time. And then I would copy that plus 2 down. So we get 2 equals 0 plus 2. You want to ask yourself, is that true? Does 2 equal 0 plus 2? Why, yes. Yes, it does. Ooh, that was an elaborate check mark. The point being, if you get something that's true, that's a confidence booster that your equation is the correct one. If this equation is the equation of the line that goes through these points, any point on that line, you should be able to substitute and get something that's true. This we would also get something that's true. Maybe not 2 equals 2, but maybe for this other one, it would be 0 equals 0. We would get something that's also true if you had substituted in this other point to confirm. So just a reminder, I think being able to check your answers is very powerful. So if there's ever a way to check your answer, I'd like to just make sure you all know how to do it. Especially, I mean, in general, I'm very passionate about empowering you guys to check your own answers, but especially right now with us being at home and you not having a teacher like 5 feet away who can check it for you, I just want to make sure you know how to do this. I'm going to go ahead and erase all of this. And I think we're on our last one. Yep. So let me move my face. I struggled with this the last time I did this, but I learned how to move it since then. This question asks, which of these graphs correctly represents the inequality 2x minus y is... Actually, I'm not going to read that because one of the mistakes students have been making is not being able to read that correctly. So I'll let you finish reading that to yourself and then go ahead and decide which of these 3 graphs would be the graph that matches with that linear inequality. And go. All right. So in order to figure out the answer to this question, I'm going to have to get this in a form where I can graph it. Right now, this linear inequality is not in slope-intercept form, and that's the form at this point we know how to graph with. So our first step before I pick a graph is I'm going to have to change this around so that y is all by itself. Now, because we're talking about solving an inequality, this is also where I'm going to remind you there is that rule we learned with solving inequalities. Do you remember what I'm thinking of? It's that rule that we said if you multiply or divide by a negative number, that inequality sign is going to change. That inequality sign is going to flip and go the other way. That is only if you're multiplying or dividing by a negative. If I divide by a positive, nothing's going to happen. It's going to stay the same. So just be on the lookout for that as we go through and solve it and change it into slope-intercept form. Our first step, if I want to change this into slope-intercept form, is remember the goal is to get y by itself. So the first thing I'm going to do is I want to get rid of that 2x. I'm going to do that by subtracting 2x on both sides. I'm doing that because 2x minus 2x is 0. So we like to say that cancels out. Over here on that right side, 1 minus 2x is something you can't subtract because they both don't have x's. So if we can't subtract them, we would just write both of them down. Now, one of the mistakes I see students make with this is what's going to be left on this left side. When these two cancel, it's not just y, it's negative y. Don't forget about that negative sign right there that's in front of your y. So sometimes students forget that and it'll change your answer. I'm going to bring down that negative y. Over here, you could, if you wanted to, write 1 minus 2x, but instead I wrote negative 2x plus 1. I changed the order of them here. Why would I want to do that? Well, I did that because we know we want y equals mx plus b. We know we want that x first. So I'm just going to go ahead and do that now so it's not an extra step for me to do later on. So I've got negative y is greater than negative 2x plus 1. Our next step is getting rid of that negative sign there. Now remember, this is multiplication. It might be easier to think about it instead of negative y as negative 1y. It's the same thing as negative 1 times y. Seeing that 1 helps students figure out what that next step is. So if you didn't already know, if you think of it as negative 1y, that next step would be dividing by negative 1. When we do that, negative 1 divided by negative 1 gives you positive. So we're left with a positive y. On this right side here, negative 2x divided by negative 1 would be positive 2x. And notice that line is going all the way across because we are dividing everything by negative 1. We're dividing both sides, the entire side, by negative 1. So we get 2x there, and then the 1 divided by negative 1. Well, 1 divided by negative 1 is negative 1. Now notice, what am I doing in this step? I'm dividing by negative 1. So what is going to happen? Well, that inequality sign is going to change. We flipped it here because I am dividing by a negative. And that's going to be important when it comes to identifying which of these graphs is the correct one. So our final answer we got for what it looks like in slope-intercept form is over here on that left side. We're left with y, and then we're left with, once we divide these, a positive 2x. Once we divide these, a negative 1. And we already talked about how that inequality sign would change. Once we've got it in slope-intercept form and see that the inequality is y is less than 2x minus 1, it makes it a lot easier for us to figure out which one of these graphs it is. Looking at this, there's a couple things we know. We know we want that y-intercept to be negative 1. So one thing you could do is, once you check that, go down and eliminate any ones you know don't have a y-intercept of 1. So I could check and see, okay, y-intercept of negative 1, y-intercept of negative 1, y-intercept of, well, it's not negative 1, so it's not this one. We also know the slope is 2. If you're thinking about slope with rise over run, that means our line should be going up 2 over 1. So I could come down to the graphs and see, okay, which graphs are going up 2 over 1? Well, this one right here looks like it's going up 1 over 2. That's a slope of a half, not 2 over 1. So I don't think it's this one. I've eliminated 2, so let's go in and check this one. This one here is going up 1, 2 over 1. So that looks good. Up 1, 2 over 1. Yep. So we're thinking it's this one. I would still just finish it out to confirm, because sometimes you might make a silly mistake and eliminate one of the ones that you shouldn't have eliminated. So we could finish checking and go over to that inequality sign. With it being a less than sign, there's 2 things you know. Because it's less than and not less than or equal to, it should mean it's a dotted line. That doesn't really help us here because they're all dotted. So there's nothing I could eliminate with that information. The other thing is because it's a less than sign, that means something about your shading. Less than means you should be shading below the line. So I could come in and check. If that's one of the first things you checked, you could have eliminated this one again because it's shaded above. That would have been a greater than sign. This one is less than, this one is less than. This is the one that matches all the information we've got though. So we want to say the correct graph is graph A. Lots of the times with these, I also like to follow up with a question, like go ahead and justify your answer. Tell me how you figured out it was graph A. All of those things we talked through could be things you could mention. You could mention, well, it's a less than sign and graph C is shaded above. It's supposed to be shaded below, so I eliminated that. The slope is 2, which means it should go up 2 over 1. B is the opposite. It's going up 1 over 2, so it's not that one. So by elimination, I figured out it was A. You could just say, like, A has all the correct things. A has a slope of 2, a y-intercept of -1. She's shaded below and has a dotted line. Any of those would be possible explanations for why graph A is correct. Guys, this is everything I've got for you. So that is our review video. Just another reminder that with these review days, there is the Unit 2 review video, which is what you're watching now. There's also going to be a Unit 2 review homework assignment. First thing, make sure you do that before you take the Unit 2 test. But the second part I think some students are forgetting or not doing is don't take that test until you've gotten the Unit 2 review homework assignment returned to you. I want you to see any feedback we left on that review, just so you can, if you miss a question, just so you can see why. Get that last opportunity to get some feedback on your work before you take the test. I'm trying to grade them as quick as possible. So it might take like a day or two after you submit it for me to get it graded, but I really do think you seeing feedback on your work, especially for the review before you take the test, is going to be really helpful before you go in and take the test. We usually try to keep the review similar to the test. So if there's a question you missed on the review, I really want to make sure you know why you missed it before you go in and take a test and maybe have a similar question to it. But that is all I've got for you on Unit 2. We are officially halfway through the material too, by the way, guys, because this class has 4 units and we are about to finish our second one. So congrats. Good job. We'll go ahead and end the video now and stop talking. Thank you guys so much for watching. Bye.